Every developer needs to know Docker. But most tutorials skip the basics and jump straight into Kubernetes. Not this one. In this complete beginner guide, I'll show you exactly what Docker is, how to write a Docker file from scratch, how to build an image, run it locally, push it to Docker Hub, and pull it inside Visual Studio. Everything from zero. Let's go! Section 1. What is Docker? Docker packages your application together with everything it needs to run, the runtime, libraries, config, and dependencies, into one unit called a container. Without Docker, you've heard the phrase, "it works on my machine." Developer has .NET 8, production has .NET 6, crash. Docker eliminates that. Build once, run identically everywhere. And containers are much lighter than virtual machines. A VM needs a full OS, 20 GB, boots in 2 minutes. A container shares the host OS, 200 MB, starts in 1 second. Section 2. Installing Docker Desktop. Go to docker.com and download Docker Desktop for your operating system. On Windows, enable the WSL2 backend when prompted during installation. This gives you the best performance on Windows. After installation, open a terminal and run docker -- version. You should see the Docker version number. Then run docker run hello world. If you see hello from Docker, your installation is working perfectly. For Visual Studio integration, open the VS installer, go to individual components, and check Container Development Tools. Section 3. Writing your first Docker file. A Docker file is a text file with instructions that tells Docker how to build your image. Every instruction creates a layer. Let me explain each instruction. From sets the base image you start from. Workdir sets the working directory inside the container. All following commands run from here. Copy copies files from your machine into the container. Expose documents which port the container listens on. And entrypoint is the command that runs when the container starts. That's a complete Docker file right there. Section 4. Multi-stage Docker file for .NET. A single-stage Docker file copies your source code into the container and uses the full SDK. That image ends up being 800 MB. Nobody wants that in production. Multi-stage builds solve this. Stage 1, use the full SDK image to restore packages and run .NET Publish. Stage 2, start fresh from the lightweight ASP.NET runtime image, just 100 MB. Copy only the compiled output from stage 1 using copy -- from equals build. The result is a production image that is 8 times smaller. This is the right way to containerize any .NET application. Section 5. Building your Docker image. Run docker build with the -t flag to set the name and tag. The format is username/imagename : version. The dot at the end tells Docker to look for a Docker file in the current folder. Docker builds layer by layer. Each instruction in your Docker file becomes one layer. Unchanged layers are cached and skipped on the next build. This makes rebuilds very fast. Run Docker images after the build to see your image listed with its repository name, tag, image ID, and size. Section 6. Running your container locally. Use Docker run with the -p flag for port mapping. The left number is the port on your host machine, the right number is the port inside the container. So -p8080:8080 means, when I visit localhost 8080 on my machine, forward it to port 8080 inside the container. Use -e to pass environment variables like connection strings. Use -d to run in the background as a detached process. Run Docker ps to see all running containers. Run Docker logs with the container ID to see application output. And Docker stop to stop a running container. Section 7. Setting up Docker Hub. Docker Hub is the official public registry for Docker images. Go to hub.docker.com and create a free account. Your username will be the prefix for all your image names. Create a new repository, give it a name like Niapi. Public repositories are completely free with no limits. Private repositories have a free tier limit. Back in your terminal, run Docker login. Enter your Docker Hub username and password. You should see login succeeded. Then tag your local image with your Docker Hub username as the prefix using Docker tag. Section 8. Pushing your image to Docker Hub. Run Docker push with the full image name including your username. Docker uploads each layer separately. Layers that already exist on Docker Hub are skipped, only new or changed layers upload. This makes subsequent pushes very fast. Push both the latest tag and a version tag like 1.0. Go to hub.docker.com and navigate to your repository. Click the Tags tab. You should see both tags listed with their digest and size. Your image is now publicly available. Anyone in the world can pull it with Docker pull your username / your image : tag. Section 9. Pulling and running in Visual Studio. There are 3 ways to use Docker images in Visual Studio. First, pull and run from the terminal. Docker pull gets the image from Docker Hub. Docker run starts it locally. Simple and works in any editor. Second, add Docker support to an existing project. Right-click the project in Solution Explorer, click Add, then Docker support. Visual Studio generates a Docker file and optionally a Docker Compose file for you. Third, press F5 to debug. Visual Studio runs your app inside a container with full debugging support. Set breakpoints inside containerized code and they work transparently. Section 10. Docker Compose. Real applications need multiple containers, your API, a database, maybe Redis. Docker Compose lets you define all of them in one YAML file and start everything with one command. In the dockercompose.yml file, you define services. Your API service uses your Docker Hub image. Your SQL Server service uses Microsoft's official SQL Server image. The depends_on field ensures SQL Server starts before your API. Containers in the same compose file can reach each other by service name. Your API connects to SQL Server using the hostname SQL Server. Run Docker Compose up and everything starts together. And that's Docker from scratch, complete guide. Docker file written, multi-stage build created, image built locally, container tested, pushed to Docker Hub, and pulled in Visual Studio. Plus Docker Compose for multi-container apps. Docker is one of the most valuable skills a developer can have in 2026. Start with one project today, containerize it, push it, and share the Docker Hub link in the comments below. If this tutorial helped you, smash the like button and subscribe for more DevOps content. See you in the next one.